So I created a library called No-redux. Don't be fooled by the name, it's still redux. It's just this library automates most of the code you write with Redux is all automated, like reducers, action creators, Redux middleware that handle HTTP calls. You don't have to write them anymore. So Redux is like almost invisible to you. So that's why I named it No-redux.
Try now.
Yeah, thanks. That's okay. Thanks. Yeah, so tonight I'm gonna talk about some of the ideas and the reasons why I created this library. I think that's probably more useful to you guys than the library itself. And then after that, if we still have time, I'm going to do a quick demo. Yeah, first take a look at this list. I believe that everyone here is familiar with those concepts because we are all React Redux developers. But actually, those concepts, they are the core concepts of functional programming. So React Redux just built upon those ideas and principles. So we're gonna first take a quick look of the some of the benefits that of using functional programming ideas. Yeah, it works. So, okay. Yeah, so side effect. What is side effect? If you write a function and then if you change anything outside your function, that is side effect. For example, if you change the UI elements directly, or you make a HTTP call, or even if you just change a shared state or variable, that's all side effects. The problem with side effects is it makes your function unpredictable. So every time you call that function, something changed, and you have no idea what changed. So if you have, like in your program, you have thousands of functions that all of them can do those side effects without any constraints, then it's pretty hard for you to manage your whole program, and that is probably like the biggest source of bugs. So if you don't have side effects in your function becomes pure. So with pure functions, it doesn't matter how many times you call it, nothing changes. So your environment stays the same. If you use pure functions, your program will be much more predictable, and you can avoid a lot of bugs. Pure functions also has some other benefits. For example, referential transparency is a fancy term, but what it basically means is if you have a pure function, and if you call the function with the same input, you always get the same output. So if you call that function the second time with the same input, actually you don't have to run that function again. You can just simply return the previous result. That is called memorization. And if you have a function with very complicated calculations, then you can improve your performance a lot. And also, pure functions are very easy to test because you don't have to mock anything. You just need to provide the input, which is just data, objects, and then you just need to test the output, which is also data. So with all those good qualities of pure functions, ideally, we should write our programs with only pure functions. But is that possible? Yes and no. No, because we still have to handle those side effects. But we don't have to handle them ourselves. The idea is to push all the side effects outside our program and let somebody else do the dirty work for us so that we can stay pure. And actually, React is a perfect example of this structure. So React handles the UI side effect for us. So we can just provide pure functions that takes the current state as input and produce virtual DOM as output. And then React will take the virtual DOM and figure out how to interact with the UI, so that we don't have to do that. And those pure functions, we call them stateless components. So ideally, we should, like all our React programs should be, all our components should be stateless components. But in React, reality that because sometimes we have to handle those lifecycle events, so we still have to create class components. But the idea is that to write as more stateless components as possible. Yeah, so let's talk about HTTP side effect. So anyone uses redux-cycles? Cool. Yeah. With the redux-cycles, it puts the HTTP calls inside action creators, so which makes the action creator not pure. So probably that's not what we want. And anyone uses redux-cycles? Nice. Yeah. So with redux-cycles, actually a lot better, because redux-cycles allows you to put all your side effects outside your regular Redux flow. So you can put them all in one place. But redux-cycles only gives you a good structure, but it doesn't actually do anything for you. You still have to make HTTP calls yourself. So there's another library that will actually help you do the HTTP side effect, which is Cycle.js. Anyone heard of Cycle.js? Yeah, Cycle.js is actually very similar to React. It uses virtual DOM to handle UI. It also has a built-in structure very similar to Redux. Also, it has a lot of libraries that handles side effects, different kinds of side effects. Those libraries are called drivers. For example, we have DOM drivers, we have HTTP drivers. So that in your Cycle.js program, you can stay completely pure. So Cycle.js is actually a fully functional library. But the problem is Cycle.js is not backed by a big company, and there are not a lot of third-party support. So we won't be able to use Cycle.js to create our full application. But somebody created another library called redux-cycles, which is just a Redux middleware. So very similar to redux-cycles, but it allows you to use Cycle.js to handle side effects in your React Redux application. But even with redux-cycles, there's a little bit of a learning curve if you're not familiar with the concept of reactive programming, which is totally complete topic. Also, with redux-cycles, for every HTTP request, you still have to write functions to provide the data needed by redux-cycles. So quite a bit of work. So I just took it one step further. So I created a library called No-redux, and then in No-redux, it just automates all the things needed by redux-cycles. So all you need to do is just to define an object that represents an HTTP call, like the URL. Then you can call the generate actions function to help you generate the action creators. Then inside the component, you can just call that action creator, which will actually produce an HTTP request object, not actually call the make the HTTP call. So that object, similar to the virtual DOM, the idea. So when the redux-cycles receive that HTTP request object, it will figure out how to help you make the HTTP calls, so that all our program here is pure. Yeah, so we're gonna look at a little bit more in detail in the demo. I want to tell you a very interesting story. So if you were here for the last React meetup in November, you may still remember a guy, an Italian guy, Luca. he gave a talk on state machines. You remember that guy? Yeah. So after the talk, I went to talk to him, and I asked some question about state machines. And then I also told him that I create a library based on redux-cycles. I didn't expect him to know the redux cycle because not a lot of people using it. But he told me he is the creator of redux cycle. What's more? Yeah, so we talked about HTTP request. What about HTTP response? So actually in Cycle.js, there's a brilliant idea of handling HTTP request and response. So they treat these two as two separate events so that we don't have to handle any asynchronous programming anymore. Because we have, when we make, we're now making a HTTP request call, but we produce HTTP request object, then we are done. We don't have to, we don't have to worry about the wait for the response to come back. So HTTP response becomes another event. It becomes the input, another input to our program. So we have another pure function taking HTTP response as input and produce action as output. Why actions? Because we want to put HTTP response on the action, and then we give it to the reducer so the reducer can put the response on the Redux store, right? But we still have to write those two functions for every HTTP request we make. So actually this process is pretty standard. So if we can make one assumption, which is whatever returned from the server, the HTTP response, we just simply put them on the Redux store without touching it, then this whole process can be automated. So this is exactly what I did with No-redux. So basically automates reducers, so you don't have to write reducers anymore. So it puts the HTTP response, or if an action doesn't make HTTP call, it's just like the action with a payload goes to a reducer directly. We just put the payload directly on the Redux store. So this is based on the assumption that we can put raw data on the Redux store. But actually, this is one of the best practices of using Redux. Anyone uses reselect? Yeah, some of them. Yeah. So if you use reselect, you are probably already familiar with the idea that we only put the raw data on Redux store, and then all your business logic, like filtering the data, sorting the data, will be in your selectors. And then you can compose your simple selectors to have like complicated selectors. So all the selectors are actually pure functions. So actually, you don't need reselect to create selectors. You don't need reselect to compose selectors. You only need reselect to memoirs the result of your composed selectors, because we mentioned before that selectors are pure functions. So if the input are the same, you don't have to recalculate the composed selector again. You can just simply return the previous result. So that's actually the only functionality provided by reselect. So with No-redux, I also implemented this function to memoirs selectors, so that if you use No-redux, you don't need to use reselect. Okay, so there's one more thing I want to talk about before we go to the demo. That is immutability. So, because if you write reducers yourself, you are responsible for keeping the Redux store immutable. But now, if you use no-redux, then you don't write reducers anymore. So it becomes no-redux responsibility to ensure immutability. So I want to talk about how I implement immutability. Anyone uses immutable.js? Cool. Yeah. So with immutable.js, it guarantees immutability, obviously. But the real benefit of using immutable.js is performance, because immutable.js, okay, let's go back. Immutable.js implements arrays and objects using a tree structure, so that if you have big arrays, you don't have to actually copy everything in the array. You only need to copy from the root node to your target node. So if you have big arrays, performance will be improved a lot with immutable.js. But if you don't have big data, big arrays, using immutable.js, there's also a price you have to pay, which is because the new data structure, you're not working with JavaScript, plain JavaScript objects anymore. So that it feels like you're using a different language. So for smaller applications, I'll prefer just handle the immutability myself. Well, actually, it's not very hard with EX6 syntax. You can just use ... to bring the references of the properties of the old object into the new object. But the problem is when it comes to deeply nested object. Say, for example, we have object like that. We have a list of artists, and then each artist has a list of albums, and then each album has a list of songs. So now, if we want to change the property, for example, the title of that song, and if we want to keep the whole object immutable, this is what we have to do. So first, we have to create a new song and change the value. Then we have to create a new array of songs, and then copy all the references of the old songs into the new song array. Then we have to do the same thing for albums, artists. So you can see that's quite a bit of work, and it's very error prone. So we need some kind of library to help us do this. One of the helper libraries is actually provided by React. It's called React Immutability Helper. That library, its syntax is very similar to MongoDB query syntax. So if you're familiar with MongoDB, you can give it a try. Another one that I use a lot is associate path function from a library called Lambda. You can think of Lambda as the functional version of Lodash and underscore. So if you use the associate path function, you can actually provide a path of the, again, similar to from the root node to your target node. You can just provide a path and then provide the value you want to update. Then the whole logic in the previous slide can be simplified as this. So it's already pretty good, but there's only one problem, is that when it comes to array, you have to provide the index to that array to find your elements in the array. But which means you have to find that index of the element beforehand, before calling the associate path. And then if you have to do it for different levels, that kind of defeated the purpose of using the associate path. So I created another package called iPath. With iPath, its idea is similar, but this time you can provide a string path. And then in that string, you can provide conditions to find your elements instead of just index. For example, you say ID equals to 1 in the artist array. In the albums array, name equals to Thriller. and then you can still provide index like songs for. Yeah, so if you try to maintain immutability yourself, you can give this library a try. And then actually in No-redux, I use iPass to handle the immutability.